My name is Andy Flatt. I'm a principal engineer at McLaren Applied Technologies. And you guys are probably thinking, why are you showing me some pictures of trains? Oh, was showing you some pictures of trains. So that is because McLaren Applied Technologies is the sort of technological arm of McLaren. We have a few different business units which we maintain technology projects for. One of them being transport, which is one of the projects we'll talk about today. We've also got motorsport, some health projects, where essentially we take data in. So with Formula One, we're taking car data in, train data as well. We're augmenting that with sensors, and we're trying to come up with some kind of clever intelligence behind that. Jonas.
If anyone from the automotive is listening in, we're also doing automotive. I'm Jonas Mende, software engineer at McLaren Applied Technologies. I joined the company about 2 years ago. We are basically, to be honest, I've been on a few of those Agile meetups before, and not just the Agile meetups, all the roundabouts. I'm quite excited to be here today. Today we are basically going to talk about a project that we've been working on for the past 1.5 years. As Andy was, something is changing, but not on the screen. It was a very interesting project for us because the project was brought to us, and at the time when the project started, the company worked in a very specific well, I would say in a very non-agile way, and it was one of the first projects within the company to really use agile methodologies and to try out some of the agile frameworks as well. And I think it's fair to say this is, the talk is called Agility in Action, but it's fair to say it's an agile love story.
The first thing to sort of go over is what we mean by agile. So we're not going to talk about the particular framework that we use, although we did use Kanban, a form of Kanban that we kind of changed a lot over time, as you do with continuous improvement. But the agile that we're talking about today is more around having the power to move quickly. And by having the power to move quickly, and also, very importantly, easily. So you don't want to make it a very difficult process to be able to move quickly and adapt to the requirements coming in. And the other aspect is the ability then to make important and the correct decisions in a way that is based off data, based off conclusions that you're able to make from information that you can gather from the system that you're building.
Let's just start. So, as we were talking about before, so one basically big customer, which is LNER, or London North Eastern Railway, or as they used to be called back when the project started, it was Virgin Trains East Coast. They have asked us to develop a system to replace their existing paper-based reservation tickets. So if you go on a train, it's still the case in some of the with some of the train operators throughout the country that you will see those small paper tickets. If you go to modern train, obviously for newly modern built trains, you have built-in seat reservation displays. So they came to us and asked us if we could retrofit existing trains with seat sensors, but the constraint was we couldn't use any of the existing electrical wiring. So they asked us to build battery-powered seat sensors with an estimated lifespan of around 3 to 5 years. So what we did is we developed sensors that you could glue to the luggage racks without drilling, because we weren't allowed to drill, that use e-paper-based reservation displays, where you basically would see the updates of where you have reserved your seat to and where it's reserved from. We also have LED indicators that show basically when you're pulling into a station, they will show the status of your reservation, and up until I think 5 minutes after departure, they will illuminate again to save some of the battery life, which is precious. And what is interesting as well is, so what LNER wanted us to do as well is, they wanted to get insight. They wanted to see how much a given train or a given service is utilized throughout the day. So they wanted to do analytics on how could they schedule their fleet, how could they schedule a given train. Also, they wanted to do things like mid-journey ticket sales. So what they asked us to do on top of that was to fit those sensors with what we call occupancy sensors. So it's actually a range sensor, a range detector that can tell if a seat is occupied or is not occupied. And what we then do is we aggregate the data, and then we have installed some software on the trains that operates third-party services to get reservation data, to get GPS data, and to then it's basically operating as the hardware controller on the train as well. It's doing all the hardware discovery, all those things. And then once it has all the data collected and once it pulls into a station, it displays the reservation information, and it then can also trigger the occupancy readings. Again, to preserve battery life, it's only taking those occupancy readings at specific points in time, because if we would do it all the time, we would lose battery voltage. So we do the 5 minutes after leaving a station and midway between two stations. The reason is that's when people move the least on the train. That's a simple reason for that. And we then aggregate the data and we provide it on two different endpoints. So one is off train, so we ship it or we send it off train to the cloud, provide an API for the customer to crawl, and the customer can then do the analytics. And then the other thing is we actually also provide an API on train that the customer can use for their on-train systems. So if you've been on an LNER train, I think they've now released a web application on the train where you can actually log on to and see how many seats on a given carriage are reserved. And if you drill down into that carriage, you can see which of the seats are reserved, which are free, which are being occupied. Yeah, these were the basic requirements of the system.
Thanks, Jonas. So the project that we had, it went through two main phases. So we had a situation where the first phase of the project, we were developing code, but we didn't have access to a train, we didn't have access to the hardware, and we didn't have access to the firmware that was being written by a third party. What we did have was we had specifications. So we had a COM specification, we had a hardware specifications which we knew was being negotiated with manufacturers to get made and sent out to us. But generally, we just had the specifications in place. And that led on to a few delays. But then once we had the hardware, we were then able to go into the second phase of the project, which is sort of post-Train Zero. And Train Zero was our first train that we went and stuck all the sensors on and then could start testing and validating our solution across the train. So you've got some issues when you work against specifications. You've got a case of you're building against a specification, but so is a third party at the same time. So they're going to be building something that may be slightly different to what you're expecting, unless you've got good communications going. When you're working with hardware, we learn a whole bunch of issues with getting things out of manufacturers on time. So the first set of by the time we agreed with the manufacturer, one of the parts that we were going to put on the board was end of lifed. So then we had to go and find another part to replace that. And then once the first boards came back from the manufacturer, we had some issues with bonding, where the vibration rigs would just make the parts not last 5 years. So that then had to go back again. So there was significant delays on actually getting the hardware. So, and then the final thing was that we didn't actually have any train to test with. So in that time when we were developing, we didn't have a moving vehicle with loads of people sitting on it, with loads of mobile phones, other trains passing it going to stations with all the interference that you get there. So we didn't really have anything kind of idea on what that would mean for the system. So the question that we had when we had our kickoff is, how do we start this thing? How do we start this project? We have a bunch of documentation, and that documentation was specifications, which kind of sounds very waterfall-y. We've got our V model, where you've got your specifications up front, and you start to implement those components by components. And the component we sort of were discussing maybe implementing first was the comms component, because that was the most spec'd out at that time. And then the idea is that by the time we'd implemented that, maybe we would know enough about another component to start implementing that. And the other school of the thought was, well, why don't we instead build the system in thin slices? And what we mean by thin slices are end-to-end pieces of functionality. So, and any of the bits of the system that we didn't have, like a piece of hardware or the firmware or the train system tell us where the train GPS is, we'd mock. We'd build our own system so we could test it. And out of curiosity, sort of, this is an agile audience, what kind of options would you go for? Would you go for maybe if you're going for a specification-based system, would you consider doing the waterfall approach? And it's an interesting one. We had a lot of discussion over it, but in the end, we decided to go for the build the thin slices and put in the additional work to build those components. And the first sort of thin slices that we came up with, we had 6 of them. We had train configuration was the first slice. So this is the idea that carriages are moving objects that can be on one train one day and another train the other day, and then sit in the depot for 6 months and then back on another train. And then after we'd done that, we then thought about, well, how do we commission the hardware? How do we stick it on the train? How do we map that to a seat? How do we do the Bluetooth pairing? So we got that working end to end. Even though we didn't have the hardware, we were then able to do that. Once we'd got that working, we then thought, well, we'll do a comms check. We'll see if we can display reservation information, get the LEDs showing across our whole train's worth of sensors. Once we had that working, we thought, well, let's go and now talk to the train GPS system. Let's go figure out how the reservation system works, build those mocks, and now we've got a train that can show the correct reservations based on the station that the train's at. And then the final steps were then to build the measurement APIs. Once we built the measurement APIs, it was then the measurement collection and then build the measurement APIs. And this was very powerful for us. So there was a few things that we got out of it. First, we turned out we knew a lot more about trains than we initially thought when we started this project, and the way they are delayed and rescheduled and maybe additional stops added. So we learned a lot about the requirements as well. What we were able to do, although we didn't know anything maybe about the collect measurement data early on we were able to ask a lot of questions to the customer about trains and schedules, and then we were able to ask them a lot of questions about how we would go about commissioning the hardware and the first things that they would be going through. So it got us in a situation where we could ask important questions very early. And the other thing, that the components and the mock things that we built, it gave us the ability to build our own integration environment and our own bench test environment that did not have any reliance on any external team, which allowed us and gave us the power to go as quickly as we wanted to with the development, because we could implement a feature, automate all the testing and everything to do that without needing any third party to aid us in understanding what we would need to do to be able to do that. Which then led on to the next point. So how do we know when work's done? So if you're working on code and you can't release it to production, you don't have a train to work on, and you're building it against mocks, this is an impossible situation for knowing that something's actually fully complete and working. Well, what we did know was that we could alter what we thought a ticket was to be ready and done to match that expectation. So we added a few steps on here, and the main ones here is that before we started working on our task, we brainstormed the rough skeleton of the test scenarios that should be covering. And this stuff is hopefully not massively new to people, but that was one of the things that was really powerful, because that aided us in understanding the requirements up front before we even started developing it. And the other sort of then thing is that we would then implement those using the integration test and build any mocks that we needed to mock out at that individual point. So this is kind of what one of our tests would look like. So we're using Cucumber. That gives us a great level of abstraction between the technical and what the business does. So we could switch out. So we've got Genius here providing the route data. The end system, we didn't use Genius, we used something else. But the test framework doesn't care, because it's getting reservation data and it's going through. And the other things we did was we commented in here tickets with our assumptions at the time. So we've got an assumption there that the train will be at the depot, because we were unsure of what would happen when we come to turnaround time at the point of implementing this test. These tests gave us the ability to recreate any kind of issue that we saw in production and then go to test that.
I'll just take the freedom to go back a few slides and actually show you what the sensors look like, because it's probably interesting. So this is what it looks like. So glued to the luggage racks, e-paper displays, LED indicators. You might have seen them if you've been on the LNER train recently. With recently, talking about, I think, half a year, something like that. And you might actually have seen that they were up there for a very long time and not doing anything. That was our integration testing period, which I'm going to talk about later a little bit. This is the app I was talking about before, that you can log onto the train and you can see basically where to go, where free seats are, which of them are reserved. Yeah, going back to work in progress, definition of done and ready, and how can we mitigate risks around not actually having a ready to be used environment. So Andy was talking about before that the project was split into two phases. In one phase, we didn't have access to any kind of hardware, we didn't have access to any train, which was a huge problem. Although at the same time we had to carry on developing, because there was no way that we could turn around and say, no, we're not going to do that. So what we did is we developed, and at this point, prior to deploying to a first train, we said, okay, we are almost feature complete, almost everything is working, we have high confidence in that our system is working, but we haven't seen it running in production yet, which is a huge risk, to take on. And if you just think about an imaginary number that you would give to the likelihood that a feature is working when you have not seen it in production, well, we just picked a number which is 50%. 50% likelihood that it works, 50% likelihood that it doesn't work for a given feature, right? So that means for every release or every feature that you implement, you add another 50% uncertainty to your system, which means your uncertainty accumulates over time, right? The more features you put into a system that you haven't yet end-to-end tested, you increase the risk, you increase the uncertainty, which is really, really dangerous. So in the end, we said, okay, the accumulated likelihood of the whole system working end-to-end, so all the features working 100% end-to-end is less than 1.5%. That's not something you can tell your customer, right? You can't tell to the customer and say, yeah, our system is 1.5% likely to work, let's just switch it on. Doesn't work that way, usually. If you have such a customer, very happy. So what did we have to do? We had to find a baseline. We had to find out how many issues we have, how many features are working, how many features aren't working. And if there are features that aren't working, we had to give an estimate of how long would it take us to fix those issues in production. This is something we could communicate. This is something we have communicated. What we have done at the same time while developing those features, because we knew we couldn't possibly know how well this stuff is working in production, we have took the time to develop monitoring and logging tools and infrastructure so that we can see how the system behaves in production. And we have also, as Andy was just showing on his previous slide, we have also written automated end-to-end tests so that when an issue arises, we can actually recreate those issues and then write tests against it, right? So then the day was there, train 0, which was our first real train, real hardware, all the end-to-end systems are there. And as you can imagine, usually in those kinds of Big Bang integration scenarios, it didn't work as expected, right? There were issues. So what you can see, obviously the graph is overly dramatic, so don't be scared. So what happened there? There were lots of problems. So there was firmware of the devices that didn't adhere to the specification. There were third-party components that didn't work as expected. The hardware didn't work as expected or as assumed by various parties. And let's face it, of course, there were bugs on our end as well, because we couldn't possibly know how the system behaves in production. But at this point, although the quality at this point perceived was very low, we also achieved one thing. The uncertainty was now very low as well. So we gained actually a lot of insight into the system by just seeing it running on a real system. And then from there, we could improve. We could address single items that we could work on and then deploy, assess individually, and then if it works on a few selected station trains, we could then deploy to the whole fleet. So this means after having a baseline, after deploying to a first set of production trains, we could actually develop improvements based on that, and then the actual quality and the perceived quality increased a lot. And at the same time, the uncertainty was maintained at the same level or actually decreased. Again, overly dramatic. So how did we do that? Again, so it's a very special environment. It's not just, when I say just, I know there's more to it, but it's not just one cloud environment that we can deploy to, right? There's a bunch of trains out there. There's impact on the customers that we have to account for. So we more or less took a standard Kanban approach and stretched it a little bit. So if you have your Kanban board, it usually stops after in review, right, and goes into done because you then deploy it. What we did, we put in a few columns in the middle. So there we have built a representative test environment based on the first train that we have seen. We have added columns for that. So when a ticket went through that, we would put it on the integration environment, and then once that is done, we have selected a few staging trains, as we call them, which is basically an A/B testing with a few selected trains. And then on those trains, to those trains, we would push the software, validate that it works or doesn't work. And then only afterwards, after having seen it running for a couple of days, we have pushed it to the whole fleet. Development approach-wise, we more or less followed a trunk-based development style of workflow with a lot of feature toggles. So one of the biggest feature toggle that we had enabled for a long, long time, this is what I was just talking about, is the screens. So the actual system was running for a very long time, but it wasn't showing any reservation data on them because they were still in our testing period. So this is one of the main feature toggles that we had there. Only at the agreed point with the customer, we then enabled that feature toggle. Didn't require a deployment. We just switched it on, and the whole fleet got the reservation data on the next day. There it is. Let's talk about automation. So again, ideally, you would have a development workflow where when an item is developed and an item is done, you could deploy it straight away. It wasn't quite that easy there because we were heavily constrained on that. So the customer told us we couldn't do deployments we could only do deployments between 9 p.m. and 6 a.m. and only if the train wasn't scheduled for a journey during that time. Also, obviously, we had to account for rollbacks. Also, we had to go through a formalized customer approval process, and at the same time, we had to do synchronous updates across the whole fleet. Again, we're talking about trains. So trains can be anywhere in the country. They can be for network coverage, and each of those trains actually has, so it has one hardware controller component, or one, which is also a software controller component that has to be updated. It has 17 so-called PCMs, which are a bridging component between the sensors and the hardware controller. And each of those PCMs also consists of three other components. So in the end, we had to update around 3,000 devices per train for a deployment. And that's not something you could just do manually, right? So we had to, because we didn't want to end up looking like that guy, which, to be fair, in the beginning we did for a few weeks. So we had to heavily invest in automation. That was the only way around there. We had to invest in automation so that in the end, on the click of a button, we could let all the trains know, here's the latest software, here's also the latest firmware. Please, after 9 p.m. and before 6 a.m., if you're not scheduled for a journey, replace all the firmware and all the devices that you have. And after you've done that, also replace all the software, all the devices that you have. And then afterwards, you can also update the cloud deployments to account for the latest changes in your system. If you want to follow that kind of workflow, if you want to deploy to a lot of targets and you want to do it often, then obviously you have to have a way to tell whether your software is actually doing what you want it to do, right? So it doesn't matter how much confidence you have in your system. You have to either verify or falsify your assumptions. And that's what we did. So as we went, we added metric and we added monitoring. So I was talking about it before, that we added monitoring and logging frameworks and tools. We didn't add that many metrics because we didn't know that much about what we actually wanted to do. So with each subsequent release, we actually added more and more metrics as we went. And he was talking about it before, that agility is the power to draw decisions quickly. And that's what enabled us to draw decisions very, very quickly and very, very efficiently. So every release, we added new metrics. And this is actually the system. So you can see lots of graphs. This is Grafana, showing lots of graphs, all of the stats that a train can have, that the fleet can have, that the cloud services can have. And this is now being used by the service desk that's operating and that's monitoring those trains as well. So one of the ideas early in the project was to design the monitoring system up front so that it would fit for the service team. We didn't do that. We said we are going to add them as we go, and it turned out quite well because we then asked them, okay, what else do you need? And they were like, no, that's actually what we need, because obviously that's what we needed while we were developing it. So that was actually helpful, or this is now helpful for them as well. This is what all the automated alerts are now based on. Yeah.
So let's quickly talk through one of our release planning. So these are 3 releases that I'm going to walk through. So we've got 1.50 at the top. That was released on the 9th of August. And for us, that release was quite a big milestone. So that was comms working really well throughout the fleet. The fleet 100% commissioned, all of the sensors sort of behaving themselves, and the comms doing a good job at not doing anything nasty to the devices. So that went out. But we did have an issue, and that issue was that although we were seeing the devices were working, there was a number of journeys that were not getting to the situation where they were able to display reservation data. And we had a fair idea of some of the issues that might be, but we weren't sure. So we planned a release. And that release was 151 with 1 ticket in. And what that did was that improved the readability of our logs for both automated tools and ourselves. And from that, we were then able to analyse those logs, the metrics and things that we'd got from that, to pick out the one issue that we wanted to fix. We fixed that one issue, and 5 days later, we released 152. And you can see that that's made a 15% bump in our journey success rate. So that's sort of a 6-day development time from releasing 151 to 2 releases later. And what we can see is a real measurable success from that release. So this is kind of what the report looked like. It was a manual report, and this is what we based our planning off. So what we're doing here is we're going off to the train scheduling system, getting down the train schedule for the whole week, for that day. We would then look at our logs and our metric system to see what journeys we actually had and which ones we displayed reservations for. And then from that, we were able to find a whole bunch of trains that we didn't do that for whatever reason. What we were then able to do is then define a few common log fragments that we would expect to see for the different issues that we get, and then automatically pick out the ones that are causing the issue. So what you can see here, and maybe not if you're far away, we have this one issue that's sort of repeating quite a lot in the system, and it's stuck in awaiting data. So that's the issue that we fixed. So when we ran the report after version 152 went out, what you can see here is we don't see that issue anymore. So we know we successfully fixed that issue. We can then do our next planning meeting where we can pick on whatever the next bigger issue is from that and get us closer to getting ready to be released and made available to the public. Just in the vein of continuous improvement, 114 I think was probably our second from last report, and I took this screenshot at the time because that's when we'd then further improved that to be a fully automated task to run those reports and it will tell us if any of those issues have regressed, which we don't see. And you can see this is a live system, so we have a reservation outage system here and a couple of other things that have been looked at. But this is great visibility on verifying that the system is actually behaving as we expect it to be.
Quick question, what's the name of this graph? Very good, good. I didn't expect anything less than an Agile Roundabout, right? So this is a community flow diagram. What we've done here, we've overlaid it with a number of releases that we've done during the time, just to prove our point about what we said before about doing lots of releases. Yeah, so what you can see is green bubbles are staging releases, as we were saying before, A/B testing periods, and blue bubbles are whole fleet deployments. And I think what you can see here quite nicely is that in the time frames where we did, so this is before train 0, this is after train 0, obviously. What you can see there is that in the time when we did loads and loads of deployments, our work in progress was very, very small. So we focused on very, very few tasks at a time to get the thing done, which helped us quite a lot to get the stuff through the system. And I think what we can see there as well is with the number of deployments going up as well, the number of closed tickets or the throughput through the system was quite high as well. So I think that's interesting to see on this graph.
So that kind of brings us to the last slide and where we ended up with the project. So at the end of the project, you kind of sit around and you think, well, what went well? What are the things we must take forward to the next project? We kind of draw a quick list, and I thought I'd share that with you today. So the mock system and pre-pod testing is definitely the absolute top one for us. That really decoupled us to be able to test and allow us to be ahead of where our third parties were with their implementation. We're staging releases to a selected subset. That did a great job at reducing our uncertainty. So by the time that we rolled out to the whole fleet, we were completely confident that we were going to make an improvement to the system. We were not going to regress it. And that was heavily helped as well by the feature flags that I mentioned below as well. We're access to the production metrics and logs the next day after doing a release. So as a coder, you code on your solution, you think you've got it to work, you put in some metrics that you know are going to either show you if you're successful or not. Being able to log onto the system that day and verify that was immediate feedback from the development you've done, which was fabulous. We've got our third party was involved in our stand-ups. That helped with getting the comms now down much quicker than if we'd done it over email. So that was definitely something we'd want to take forward. The way that we did continuous improvement was awesome. So we would sit in a meeting room, we'd talk about things, we would pick 1 or 2 tickets that would go straight onto the release and be part of the release. So an example of that, we decided that our builds were taking too long. They were taking close to an hour. A ticket went on the board to make them last 20 minutes. 2 days later, the builds are 20 minutes long, and that's part of the next release. And we all embraced DevOps. We all embraced the automation. We all drove that forward. And the final point, which I hope we've showed by the data that we used here, is that we were always working towards goals and measurements. So we knew exactly what we were trying to do with the next release, and we were able to measure that. Thank you very much.